Okay, the next module is module 19. And for whatever reason, they have chosen to repeat a bunch of topics that you've already seen before. So you can refer back to the videos for these, and I'm just going to write which module each one is in. So for this first one, finding the x-intercepts in vertex of a parabola, this is in, oops, I need to get my annotator here. This is in module 13. Okay. Your next one with finding the zeros of a quadratic given its equation, that is also module 13. The next one, matching, that is module 14. Okay, so again, if you need help with these, go back to these notes. It's the same topic. It's just, in fact, a lot of you will have tested out of a big chunk. It's these 9 are repeated. So it's very possible that they don't even come up for you because you got them back in those modules and you never lost them. Okay, but if you lost them, they want you to get them back again. So whatever. Okay, this is module 15, as are the other 2 here. Okay, this one is module 15. And this one is also module 15. And then the last one that's a repeat is from module 16. Okay, so I don't know why they decided to do this, but that's just what they've got. So we'll go with it, okay? Which means that you only have 6 new topics. Oops, I can't scroll down here. So you got the 6 new topics in module 19, okay? So we'll go over how to do those, though. So module 19, I'm just going to write here for the first 9 topics. See the video for module 19 to see where they were covered in previous modules. And I'll even say module number 13 through module number 16. Okay, so we're going to start with the first new one, rather than repeating all those again. Solving an equation of the form log base b of a equals c. So there's our first new topic of the 6 new ones in module 19. Okay, so most often you're going to want to switch to exponential form with this. Okay, so remember, log base b of a equals c can be written as b to the c equals a with your loop and swoop. Okay, so an example of this one, they have log base 49 of x is 1/2. So we're going to loop and swoop it. 49 to the 1/2 power is x. And we know that the 1/2 power is the same as the square root. So it's 7. Easy as that. We can do one more if you want. Pretty sure they're not going to get any more difficult than these. They are. It looks like they do have a lot of fractional exponents though. So we'll do one with a negative exponent. Log base 4 of x is -3. So we do 4 to the -3 is x. So that's 1 over 4 to the 3rd power. And 4 to the 3rd power is 64. So 1 over 64 would be your answer for that one. Oops, this one would be 7. Okay, so it's going to test you on those fractions and negatives. It looks like almost every problem is either a fraction or a negative number where C is. Okay, so use this as a model for you. Okay, the next one we have is solving a multi-step equation involving a single logarithm. And we have a few problem types for this one. They call this one problem type 1. Okay. So this one we have log, and again, put these in exponential form. Okay, it's just a little bit more complicated than the one that we just did. Log base 5 of negative 3x plus 8 equals 1. Okay, so loop and swoop, 5 to the first power is negative 3x plus 8. And that's some 7th grade math there for you. That shouldn't be too hard, okay? So just don't make any silly little mistakes. 5 to the first power is 5. Subtract 8 from both sides, so negative 3 is negative 3x, so x is 1. Okay, I can do another one here, see if anything tricky comes up. Doesn't really look like it. Okay, we'll do log base 2 of 3x minus 4 is 3. So 2 to the third power is 3x minus 4. That's 8. So 12 would be 3x, and x would be 4. Okay. Let me just make sure in the explanation I'm not missing anything for these. I don't think I am. Okay. Not too bad, right? Next one, another multi-step problem. Okay. I'm not going to write out the whole title. I'm going to do same. So same, but problem type 2. Okay. So these are going to be similar, but they'll be an exponent. So we have, a coefficient. 6 log base 4 of x plus 19 is 12. Okay, so we just have that additional step of dividing by 6 first. So log base 4 of x plus 19 is 2. 4 squared would be x plus 19, so 16. Okay, and then we'd have negative 3 then as x. Right? I don't think we need to do another one of that one. I'll take it back. Here's a slightly different one. 7 plus log base 4 of negative 5x is 9. Okay, so rather than dividing to start off with, we need to subtract. So we got to get that 7. Okay, so log base 4 of negative 5x is 2. And now we're good. 4 to the second power is negative 5x. 16 is negative 5x. So x would be negative 16 over 5. Okay, and you can just leave it as a fraction. All right, let's get another topic here. Next we have solving a multi-step equation involving natural logs. So you just have to remember that the base is e. Okay, so we have 5 plus the natural log of x plus 4 is 2. Okay, so we got to get that log by itself again by subtracting 5. Okay, and now when we put it in exponential form, just remember that base is e. So e to the negative 3 is x plus 4. Okay, it looks like they're going to let you use your calculator for this, to just do e to the negative third on your calculator. If you didn't have a calculator, this would be 1 over e cubed equals x plus 4. And then we can subtract 4. So x would be 1 over e cubed minus 4. But it looks like they're going to let you use your calculator, so you should get negative 3.95. Okay, we can do another one. See if we can get one a little bit different. Yeah. 2 times the natural log of x plus 2 equals negative 2. So we can now in this case divide by 2. So the natural log of x plus 2 is negative 1. E to the negative 1 then would be x plus 2. So that's 1 over e. And then subtract the 2. Okay, and you should get about negative 1.63. Okay, just make sure you route correctly when you put in your answer. All right, we are cruising through these. This should be a nice module for you guys. The next one. We only have 2 more to go. Solving an equation involving logarithms on both sides. And this is problem type 1. Okay, so this one, they're going to have to be the same base. Okay, so we want to try to get your logs together. Okay, so that we can use our properties of logarithms to do that. So log base 5 of x plus 8 equals 1 minus log base 5 of x plus 4. Okay, so again, our goal is to get logs on one side and only logs, so alone, and then combine. Okay, so we're going to add the log base 5 of x plus 4 to the left-hand side. So log base 5 of x plus 8 plus log base 5 of x plus 4 equals 1. Okay, and so now we can combine that to make it one log. So remember your sum of logs rule, our product of logs. We can write this as x plus 8 times x plus 4 equals 1. Okay, now you can loop and swoop. 5 to the first power is x plus 8 times x plus 4. And that's a quadratic. It's not factored the way we would want it to be factored because it's not set equal to 0. So we will expand it and then set it equal to 0. So 5 is, if I expand this, I'm going to have x squared plus 12x plus 32. Get the 5 to the other side. And now factor it. Your zero product property only works when the product is 0. Okay? So now we get an answer of x equals negative 3 or x equals negative 9. Okay? I'm going to go back here. So we got all the logs on one side here. We combined here. We're going to put it in exponential form. And then we expand. We want to get it set equal to 0, factor, and then we solve. Okay, now here's the kicker on these. You're going to have possibly extraneous solutions. Okay, so we want to check because you can't take the log of a negative number. Okay, that doesn't mean that neither of these work, because if you go back up to our problem, it was log base 5 of x plus 8 equals 1 minus log base 5 of x plus 4. So we don't have to worry about x being negative. We have to worry about x plus 8 or x plus 4 being negative. So if x is negative 3, we'll have log base 5 of negative 3 plus 8 is 5 equals 1 minus log base 5, negative 3 plus 4 is 1. Okay, log base 5 of 5 is 1. Log base anything of 1 is 0. So that works. We're good. Okay, if I want to check x equals negative 5, I'm sorry, negative 9, I'd have log base 5 of negative 9 plus 8 equals 1 minus log base 5 of negative 9 plus 4. Okay, and I can see right away, I'm going to have log base 5 of negative 1 and log base 5 of negative 5. I can't solve those. You cannot take the log of a negative number. Okay, so that doesn't work. Okay, so my final answer is just that x equals negative 3. All right, let me do another one for you. This one we have log base 2 of x minus 5 equals 2 minus log base 2 of x minus 2. Okay, so I'm going to follow that first step. I'm going to get the logs on the same side. I'm going to combine them. Okay, now I'm going to expand. And I'll have x squared minus 7x plus 10. Okay, write it in exponential form, so 2 squared would equal x squared minus 7x plus 10. Set it equal to 0, so 2 squared is 4, so I'll subtract 4 from both sides. Okay, and then factor that. And then I'll get x is 6 or x is 1. Okay, now I'm going to check my answer, and I'm going to not even take as much time to do this one. Okay, my original expression. Okay, if I plug 6 in, I'm not going to get any negative logs, right? 6 minus 5 is 1, 6 minus 2 is 4. That will work. I could show the work for it. But if I plug 1 in, I'm going to have the log of negative 4 and the log of negative 1. So that's not going to work. So my only answer will be 6. Okay. All right. One more topic. The last topic we have is solving an equation involving logarithms on both sides. And this is problem type 2. This is actually a little bit of an easier problem. Okay, so in this one we have log of x minus 3 plus log 2 equals log 13. Okay, our goal here is to just get a combined log on each side. Okay, so we want log base b of c equals log base b of d. And then what we can do is say then that c must equal d. Okay, so over here on the left-hand side, I can write that as the log of x minus 3 times 2, and that's the log of 13. Okay, so x minus 3 times 2, or 2x minus 6, has to equal 13. And it's as easy as that. So then 2x is 19, and x is 19 halves. Okay, again, I want to check it to make sure that it doesn't give me a negative logarithm here. 19 halves, that is 9.5. Okay, so I can tell it when I go back to my original problem here. If I plug 9.5 into there, I'm going to get 6.5. Okay, and that's fine. All right, that's going to work. Okay, and in fact, then I could combine those is to be the log of 6.5 times 2, which is the log of 13, equals the log of 13. We'll do one more of that type. And then we'll be done. Okay, this one is log x equals log x minus 7 plus log 3. Okay, so log x equals log x minus 7 times 3. So we can drop our logarithms. X would equal 3x minus 21. Okay, we want to solve for x, so I'm going to add 21 to both sides and subtract x. So 21 over 2 is x. Okay, and again, that is 10.5. So if I plug it back in, I'm going to have the log of 10.5 equals the log of 3.5 plus the log of 3. And 3 times 3.5 is 10.5. Checks out. So x is 21 halves, or 10.5. Okay? And that's it. That's it for Module 19 then.